Good afternoon, class. Thank you. You can sit down. All right, then today we'll be looking, we're still looking at graphs and curves, and we'll be looking at other graphs apart from what we've already done. We've looked at linear graphs and quadratic graphs, or the parabola. Okay, now we'll look at some other graphs. But before we do that, we have to look at the homework that you were given. You were given question 3, question 4, and question 5 on quadratic models, the previous exercise. So question 3, Jake will answer question 3 on the board. Question 4, I think it's Hekoi. Question 5, it's Gabriel. Okay, question 3, Jake. And use the pointer too if you want.
Question 3 reads, a man wishes to make a chicken run using an existing wall as one side. He has 16 meters of wire netting. 1. If the width of the run is x meters as shown, find the length and show that the area of the run is given by the equation a equals x 16 multiplied by 16 minus 2x. For a, since it's labeled as 16, it's 16 minus 2x, therefore the length is equals to 16 minus 2x.
Where's this one? Here.
For question 2, using values of x from 0 to 8, draw up a table of values for a equals x multiplied by 16 minus 2x, which we've done over here. And draw the graph of the equation, the graph we have drawn over here. Question 4, find the maximum area that the chicken run can have. Using the tables, we can see that the maximum is 32 meters square. And the last question, what dimensions will have the maximum area? Since x is already given that it's 4 centimeter, which is the width, you substitute and then solve for 16 minus 2x, you get the length, which is 8 meters. Thank you.
Good. Okay, thank you, Jake. That was question 3. Okay, when we, just in case you see this question again, in grade 12, we do the same question, but we do it in Introduction to Calculus. And you will be looking at things like what are the width and the length for maximum area, but then you don't draw the graph. You will use a different method, which is algebra only, to find the length and the width for the maximum area. Okay, but it's exactly the same question, but you'll use a different method to solve for the length and the width. Now make sure when you see it, you know that you've seen it already, and it will be hopefully a bit easier for you then. All right, next question, Hekoi. Question 4. Well done, Jake.
Question 4 reads, if the perimeter of a rectangle is 80 meters and its length is x meters, what is the breadth in terms of x? Here we draw the rectangle in which x is the length. We all know that perimeter equals 2L plus 2W. So 80 equals 2x plus 2W. We came up with 80 minus 2x equals 2W. Therefore, the breadth is equals to 40 minus x. For B, it reads, show that the area of the rectangle is given by A equals x outside the brackets of 40 minus x. We can see from this diagram that the length is x and the width is 40 minus x. Over here, we substituted the formula, got an x value from the table here. We got 5, so 5 outside the brackets of 40 minus 5, in which we got 175 square meters. Therefore, this solution here proves the formula, this formula. C, it reads, draw the graph of the function representing the area. What are the coordinates of the vertex? Okay. We used intervals of 5 for the horizontal axis and intervals of 50 for the vertical axis, and this is the shape of the parabola. The coordinates of the vertex are 20 and 40. As you can see from the table, 20 and 40, and from the graph here, 20 and 400, sorry. For D, it reads, what values of x are meaningful in this problem? The values of x that are meaningful in this problem are x values ranging from 1 to 20, because as the length increases, the area also increases. It's impossible for the area to decrease when the length is increasing.
Question E reads, find the area of the rectangle when x is 25 centimeters. So when x is 25 centimeters, we substitute into the formula x outside the brackets of 40 minus x. We get 1,000 minus 625, which the area is equals to 375 square meters. For F, F reads, find the value of x when A is 300. When the area is 300, we substitute into the formula again. We got two values. We obtain 2x values. X is either 30 or x is equals to 10. If the area of the rectangle is 300 square meters, what are its possible dimensions? Okay. Because the meaningful values of x to the problem ranges from 1 to 20, the length will be 10 meters and the width will be 30 meters.
One more. Mike.
G reads, what are the dimensions of the rectangle which encloses the maximum area? What is this maximum area? As you can see from the graph, the maximum area is 400. So if we substitute 400 into this equation, we'll get 0 equals x squared minus 40x plus 400. We'll vectorize the equation, get x minus 20 times x minus 20. Therefore, x equals 20. So the length would be 20, and the width would also be 20.
Good. Thank you, Hekoi, Velma, and Taumaku. For the rectangle to actually contain maximum area of 400, it will have to become a square with length 20 and the width 20. Maximum area is 400. Okay, very good. Next question is question 5. Who's doing question 5? Oh, one of the 3 Gabriels. Question 5. Read it, please.
Question 5 reads, the height h meters of a cricket ball after being struck by a batsman is given by the equation h is equal to 1 plus x minus x squared divided by 40, where x meters is horizontal distance that the ball has traveled from the bat.
Okay. Just press that and tell me. No, bottom.
Draw the graph of h equals 1 plus x minus x squared divided by 40. To draw the graphs, we've done the tables, value of tables as shown on the graph paper. Question A, how far would the ball travel before hitting the ground? The ball traveled 41 meters before hitting the ground. To prove that, we've used the quadratic formula, which is minus b plus or minus the square root of b squared minus 4ac all over 2a. Then we came up with the
You just use the graph.
answer, which is 40.975. We disregarded the negative answer because in this case it is irrelevant. So rounded the nearest, it is 41 meters. B, what is the greatest height reached by the ball? The greatest height reached by the ball is this 11 meters, which is the vertex or the turning point. C, if a fieldsman caught the ball at a distance of 40 meters from the batsman, at what height was the catch made? The catch was made at 1 meter.
What? 1 meter. Is that all? Okay, well done, Gabriel, and those who helped him do the question. Okay, why do you think when x is 0, h is 1 meter here?
That fellow throwing the ball is 1 meter, the height of that fellow.
Are you sure?
The ball hits the bat. When the ball hits the bat. So.
When the ball hits the bat, what does it mean? H represents the
Height.
vertical distance and x represents the horizontal distance. Horizontal distance here is 0, this one is 1. Explain that again. Does that mean the person throwing the ball is 1 meter tall? He will be a small fellow, please. What? The other reason you gave.
The bat, it's 1 meter above the ground.
Okay, the ball is 1 meter above the ground. I'm not a cricket player, but I watch cricket. Okay, when the bowler throws the ball, the person who hits the ball actually hits it at 1 meter above the ground. So that's when the ball hits the bat, 1 meter above the ground. Okay. This question also, it's given again in grade 12 in calculus. Like I said, you will have to use a different method, which is actually called differentiating, to work out the answers. We don't draw the graph, but what I'd like you to remember is to at least maybe remember the shape of the graph that you drew, especially the maximum height. In this case, it's what? 11? That's how high the ball travels. Okay. Any questions? All right, thank you again. You all did very well, those who answered the questions. All right, then the next thing we'll look at is other types of graphs. Okay, I've got an example. Or what you can actually do for graphs and curves, if you enjoy plotting graphs, you can come up with your own equation. Just come up with an equation, substitute certain values for x and see what the y values are, and then plot the graph and see what shape of the curve you get. Okay, you can come up with any equation and then plot. Okay, this one is the table of values below shows the ordered pairs for x, y equals 6, which is also y equals 6 on x. I've got the table of values. I think it's number 1 on the exercise 8.6 on your worksheet. Okay, the curve that is produced, which is what I've got here on the board. The curve produced is known as the hyperbola. Specifically, it's known as the rectangular hyperbola because it's on these two sides. Note on the axis you have 4 quadrants. This is usually called quadrant number 1 on this side, quadrant number 2, quadrant number 3, and quadrant number 4. So if you plot y equals 6 on x, all right, you will get a curve here in the second quadrant and a curve here in the third quadrant. Sorry, in the fourth quadrant. 1, 2, 3, and 4. Now, the question that is asked here, how is it different from the other graphs that you have drawn? By looking at the graph, just ignore this line first. Just look at the curves. How is it different from the, we've drawn linear equations and graphs of linear equations, and we've drawn graphs of quadratic equations. 1%, please. Kyle, how is this graph different from the lines that we've drawn and the parabolas that we've drawn?
They don't touch the axis.
The curves do not touch the x-axis. And there are also 2 curves, especially if you've got the negative values of x and positive values of x. If you've got positive values of x only, the graph will only be on the right-hand side. If you've got the negative x values only, the graph will be on this side. Now, why isn't there an x-intercept? Why isn't the graph touching the x-axis? Any idea? Okay, let me just rephrase the question again. When does the graph touch the x-axis? What value of y will give you a point on the x-axis? Siegfried? Pass the mic to Siegfried.
0.
0. Okay, he says when y is equal to 0, that is supposed to be at the x-axis. If I can just draw a line. Okay, if this is the graph of y equals 2x minus 2x plus 4, y equals minus 2x plus 4. When y is equal to 0, x will be equal to, that's what he says the value for y must be 0 at the x-intercept. Okay, 0 equals minus 2x plus 4. I get minus 4 equals minus 2x, and x is equal to 2. Is he correct? Because he said at the x-intercept, y is equal to 0. Is he correct? Is he correct? Yes. I'm just trying to make sure you are sure of what you are saying. Okay. The value of y must be equal to 0 at the x-intercept. The value of x must be equal to 0 at the y-intercept. You were taught to sketch straight lines. You find 2 points, the x and the y-intercept. Okay, my question was, what must be the value for y at the x-intercept? Siegfried said it must be 0. The equation of this graph is y equals 6 on x. If I make y 0, I will get 6 on x. What's the value for x when y is equal to 0 in this case? You're saying 0. You're telling me x equals 0 when y is equal to 0. You're telling me when x is 0, y must be equal to 0. Then why haven't we got it on the graph? If you're telling me x equals 0 when y is equal to 0, then it's this point. The graph is supposed to pass through this point if you're telling me that if what you're telling me is true. If y is, have a look at this equation here. When y is equal to 0, you are telling me x is 0. True? Okay, let's look at it another way. Now someone is saying y equals 6 when x is 0. Okay, if I wanted to find the value for y when x is 0, what is 6 divided by 0? 0? You are telling me 6 divided by 0 is 0. Who told you that? Is that what they told you in grade 9 and grade 10? Okay. You are supposed to know. Don't depend on the calculator. That's not your brain. Okay, I'll tell you a very simple why there is no answer to 6 divided by 0. The calculator tells you error because it cannot calculate that. There is no answer to 6 divided by 0, any number divided by 0. You see, if I divide 6 by 3, I get 2. Because I can multiply 2 by 3 and I get 6. If you are telling me 6 divided by 0 is 0, then you are saying 0 times 0 is 6, which is wrong. So anything divided by 0 is undefined. There is no answer to it. So we just say undefined here. There is no value for y when x is 0. There is no value for x when y is 0 in this equation. It does not exist. That's why you cannot plot it on the graph. That's why the graph actually has a curve only on this side. Then you stop and then plot the graph on this side. Okay, that means this graph is actually discontinuous. The parabola is continuous. This one is, it's a discontinuous graph. How do you spell discontinuous? Did I miss an E somewhere? Okay, but the graph is discontinuous. Now the next question. So, sorry, from now the graph, the equation in this form, y equals whatever number divided by x, you will always end up with a graph like this, where there will not be any x-intercept. If this value is negative, if the numerator is negative, the graphs, the curves will be on these two sides. You are going to see that with one graph you are going to plot for homework. It will be on these two sides. There will not be any x-intercept. Okay, the next question that we've got is the graph symmetrical? If it is, what is the equation of the line of symmetry? Okay, the graph is symmetrical, actually has two lines of symmetry. One is this line here, which is y equals x, because if you got this and then you maybe tore the graph in half like that, if you folded it, then this side will actually fit perfectly onto this side. So one axis of symmetry is y equals negative x. There is another one, which is y equals x. Okay, that's the line y equals x. It's also a line of symmetry. And like I said, if you folded the paper in half, this part, because if you continue to draw the graph further and further this way, if you fold the paper in half, this side will fit onto this side as well. So there are two lines of symmetry. One is y equals negative x and y equals x. Okay, two lines of symmetry for this one. Now, you're going to plot the graph that is on your worksheet, y equals 1 on x. First, fill in the table of values, and then see if you can plot. You have 5 minutes to do that. Okay. For the table of values, when x is negative 4, y is negative 1/4. When x is negative 2, y is negative a half. When x is negative 1, y is negative 1. When x is negative a half, y is negative 2. When x is negative 1/4, y is negative 4. When x is 1/4, y is 4. When x is a half, y is 2. When x is 1, y is a half, 1. When x is 2, y is a half, and when x is 4, y is 1/4. Okay, I've got the graph drawn on this same axis, the one in blue. Okay, this and this. That's y equals 1 over x. Okay, just have a look at these two graphs. Y equals 6 on x, the red one, and y equals 1 on x, the blue one. Why do you think the blue one is much closer to the axis than the red one? Okay, the blue one is y equals 1 on x. Red one, y equals 6 on x. Why do you think the blue one is much closer to the origin, or much closer to the x and y axis than the red one? Any idea? Yes, Pond Relay? Pastor Mike?
Because the numerator of the equation is 1.
Okay. For y equals 6 on x, this 6 is greater than 1. Okay, if the greater the numerator, the further away the curve is from the axis. Like what we said about the parabola, y equals ax squared plus bx plus c. What did I say about the value for a? It determines two things. One, quickly, y equals ax squared plus bx plus c. I said a determines two things about the graph. Tell me one. Does anyone remember? Anyone remembers? Daniel? You don't remember? Okay, hopefully I won't repeat this again. One, if it is less than 0, the graph is upside down. If a is negative, the graph is upside down. If a is positive, it is upright. If, let's say, a was 1.5, if one had a1 and the other had a1/2, then the graph where a is a half will be much wider than the one where a is 1. So the smaller the value of a, the wider. It also determines how wide or how narrow the parabola is. So those two things are determined by the value of a. All right, in this case, the distance from the axis is determined by the numerator. The bigger the numerator, the further away from the axis the curves will be. Okay, so that's why this one, the blue one, is closer to the axis than the red one, because 1 is less than 6. Okay, this is what you are going to do for homework. You are going to draw two graphs on one set of axes only. Y equals 2 on x, y equals -1 on x. That's not all. Question 3. I hope there's question 4. No question 4. Okay, these types of curves are called hyperbolas. So the keyword to the pilot teacher is hyperbola. All right, please stand. Good afternoon, class. Thank you.
National Education Week 2003.
Join the Department of Education this year in celebrating the National Education Week from the 6th to the 10th of October 2003 with the theme
Relevant Curriculum for a Better Future.
Kisim Save Long Kama Pem Good Plus Innan Long Time Behind.
Mauri momokani ai diba tahua vaira ai, mauri namona noholaya totona.
Our reform curriculum promotes Papua New Guinea race. National Education Week 2003. Relevant Curriculum for a Better Future.